So we need a function which is changing smoothly along the x-axis. Can you see that for discrete distribution that is not the case? For example, if you see this, whether you see this lookup table or whether you see this or whether you see this, even this one, even these equations which you write, yeah? Let me tell you, for Bernoulli distribution, what do we write? Yeah, we write p to k, 1 minus p to 1 minus k. Now you may think that this is a nice function, but it's not a nice function because it is only defined, this nice formula only works when k is 0 or 1. Outside that, it is 0, so it is not a nice function. Are you getting me? So let me just summarize the problem with these. None of these functions is amenable to calculus. We need functions that are easy to deal with in a calculus thing. And that brings us to what we call degenerating functions. And it will, if I pick one of that representation where a value k is mapped to the probability associated with that k, and k can belong to some set. The only problem with this generating function is that you have to assume all the natural numbers, including 0. Yeah, so 0, 1, 2, and so on. You must assume that your set of values is the whole set of non-negative integers. This is not a problem because if your actual set is finite, for all the other values you can assume 0 probability, so it's not a problem. Yeah. So you can still go with k can be expanded to all the natural numbers, including 0. So let me illustrate this with a few examples. Okay, sorry, I forgot to mention this part. Yeah. So I replace this with something that looks like a polynomial. So I retain that probability here as a coefficient, and I sum from, and then I multiply each probability with z. Z is any variable, and I raise that to k. Yeah. So it will look like this for those who are not happy with this. So it will look like this. The first term will be p0. The second will be p1z. The third will be p2 z squared, and so on. Yeah. And if, for example, if your distribution stops here, let's say there is nothing further, so all the others will automatically be 0. Yeah. So it will be 0 times z cubed plus 0 times, and so on. So now, can you see that this is a different function, but this basically contains the same information? Why? All the probabilities are included in the coefficients. So you have not lost the probabilities, and all the values, where do the values appear? They appear as exponents. So I have retained my values as exponents, and I have retained the probabilities as coefficients. Let's see this for a few simple examples. So the Dirac distribution delta n has only one value, and that value is n. And what is the probability at that value? 1. Yeah. So if you look at that, all the coefficients must be 0 except which one? Z2 n. That is the only non-zero coefficient. That will be 1. Everything else is 0. So here is the maplet representation of distribution. Here is the. Now think about this. This is just your simple polynomial. You can differentiate it with respect to z. You can integrate it. You can do whatever you want with it. Another example, Bernoulli distribution. And here I just write it so that you can remember that you have values 0 and 1. 0 is associated with probability 1 minus p, 1 is associated with probability p, and this is how you write the maplets: 0 to 1 minus p, 1 to p. And here it's so easy to write. Yeah, you write this so that the 0 becomes the exponents and the probabilities become the coefficients. So 1 minus p, z to 0th. This is z to 0th, and that's why it's 1. And p, z to 1th. Yeah. And do compare the left side with the right side. This is a very nice function. We can do everything with it. And last example is discrete uniform distribution, where the values of k are from 1 to n, each with probability 1/n. Yeah, you represent it here in this way. K goes from 1 to n. And here, 1 over n, you will have the same coefficients, 1 over n, from 1 to n, z, and all the other coefficients will be 0. So the strengths of this, and this is what we call the PGF, probability generating function, because you can read the probabilities. If I give you a PGF, the PGF contains two pieces of information. It contains the probabilities as well as the values. Yeah. So you don't even need to discuss, you don't even need to say separately what is the support, because the PGF, the expression itself, for example, this expression is telling me what is the support, because it goes from 1 to n. Yeah. So that's clear. But that's not the real advantage. Yeah. So you, at the moment, you might think that it's just an economic, parsimonious is just another word for economical. It is just a parsimonious way of writing the distribution. But there is the real advantage is actually much more than that. Yeah. So let me start with a sequence. So I have two sequences, A and B, and I will write it in a simple notation. So let's say the sequence A has elements A1, A0, A1, and so on. Let's call this sequence A. And let's say sequence B is B0, B1, and so on. So I call that sequence A and I call that sequence B. And I know that for these sequences, I can write a generating function. What will be the generating function for sequence A? This one. Why? Because each value, A0, A1, is multiplied by the corresponding power of Z. Yeah. And because I don't know which ones will be 0, so I can write the full expression. And when I know the values, they will be 0, so I don't mind. Here I write the PGF of B, and I multiply these two. So I multiply this series. Let me tell you something about names. You have heard two names, yeah? You heard polynomials. So is this a polynomial? Can anyone tell me? Is this a polynomial? Yes or no?
Yes, it is.
Unfortunately, no, because polynomial must end. It must be finite.
Oh, okay.
So polynomial of degree. So because this is actually an infinite series in general, unless I know, if I am sure that n will the coefficients will be 0 after some, then it is a polynomial. In general, you use another name. And what is the name of this? If it is not a finite.
Geometric series?
No, I don't know anything. Geometric requires coefficients to be. Yeah, it is. It is. Yeah, it is. You can think of it as a geometric series, but there is a problem. There is a problem because you do not know about A1 and A2. If all these coefficients are constant, sorry, if they are all the same, then it is a geometric series. Yeah.
Power series.
But if they are not the same, then geometric series के लिए क्या है कि every next term is just a multiple of the previous. Yeah. Can you say that between these two, for example? Can you say that this is a multiple of that?
No.
Yeah. And by multiple, I mean I use the same ratio. So the ratio between these two is not the same as the ratio between these two because these coefficients are different. So the name for such a series is called a power series. You must have heard this. Power series, yeah. So geometric series is a special case of a power series. And CVT, you must have heard this name. Can you give me 2 examples of power series? More examples other than geometric series? How about this one?
Taylor series.
And another one?
Lawrence.
McLaurin's and so on. See? So you know what I'm up to. Yeah? So let me now multiply these. So do you agree with this expansion? First multiply the constants. Yeah. So A naught, B naught. Then I just gather coefficients of Z from this side and from this side. For example, this Z can multiply B naught and this Z can multiply A naught. So I gather them here. Agreed? And similarly, I can go for Z squared. If you think about it, you can gather it. So the product is also a power series. Yeah. So I can give name to this. So let me call this C naught because I started with 2 series. I had a series A, I had a sequence A, a sequence B, and I know that when I multiply the 2 PGFs, that product is a PGF, and that PGF must be the PGF of some other sequence C. So I'm just calling this C naught, and I'm just calling this C1. I'm calling this C2 because you see 1, 1, 0, 0. So I want to write this in the form of another power series. So I know this must be the PGF of this new sequence. Are you with me? Now look carefully about these coefficients of the product. If you think about this, for example, if you focus on this one, you have A0, B1, A1, B0. What is common between these two? These indices 0 and 1, when you add them, 0 plus 1 is 1. 1 plus 0, 1. So the sum is 1. Sum of the indices is 1. What is the sum of indices here? 2 plus 0, 1 plus 1, 2 plus 0. So the sum is 2. So which means that I can now generalize. Yeah. When I think about CK will have this same form. I will have to multiply coefficients, and it has to be in such a way that these two add up to K. So if this is I, this must be K minus I, because otherwise they will not add up to K. Yeah. So, and remember, for 2 I have to start from 0. So when K is 1, I have 2 terms. When K is 2, I have 3 terms, and so on. So for K, how many terms do I need? K plus 1. I have to start from 0 So 0, 1, 2 up to k. And you can replace this by a much easier to read formula. I just write aibj and I require this summation, yeah, to have I plus j equals to k every time. Does this remind you of something? What is going on here? This means that I have two sequences and I did something between those two sequences to get a third sequence. What is that something? What is that operation? Can anybody guess that? You know it already. You know it from another course. It's very unusual because I thought you would actually guess that very easily. There's nothing fancy here. It's very easy. I just have a sequence and I have another sequence. I multiply. You get a third product, and that product is the PGF of another sequence. In signals and systems, you have seen this. Yeah. Even now, you should not. Here's the problem with notation. Yeah, so you're not happy with notation. If I, instead of AK, you see, it was AK. If I had written AK like that and BK like that and CK like that, you would be very easy to spot this. What is this? Can you name it now?
Convolution.
Yeah, convolution. What do you do in convolution? You do exactly the same thing. Rewrite it in this notation and you will know what I mean, yeah? So if this is I, this will be k minus I, yeah? And then I sum this from 0 to k. Isn't this what you do in convolution? So basically, you have established that convolution of two sequences. I already told you that discrete time signal is a sequence. The convolution of two sequences is basically the simple product of their PGFs. So if I take the PGF of A and if I take the PGF of B, I will get the PGF of what?
C.
C. Yeah. Which one of these is easier? Is this easier or is this easier? Here I have sequences. They are not smooth functions. And because they are not smooth functions, you see the operation is also, convolution is horrible to imagine. But here you have a nice function, a nice either a polynomial or a series. No, yeah, of course. This is actually a series. Remember, A and B are sequences, and the PGF is a series, a power series. You multiply two power series, and you get another power series. So here, you are into calculus, CVT, and here, you are into something which you don't like probably. Yeah? So, but now I'll tell you how convolution arises in probability. But before that, let's have a formal definition of this new thing, probability, because what we did so far was not specific to probability. I can have any sequence. But now, I want this definition to be specific for one sequence. and that sequence is the sequence of my discrete PDF, because discrete PDF is a sequence, yeah, fx, and because in this generating function I will always assume that k belongs to this set, yeah, even if it does not, I will assume 0 probabilities, yeah, because you can always expand your set of values to this set by allowing probabilities to be 0. So these are sequences, yeah? So I will have fx of 0, fx of 1, and so on. I get a sequence. So I multiply each value by the respective power of z, sum this as a power series, and that will be the generating function for x. So it's called the probability generating function. Why it's called not any generating function but probability generating function? Because the coefficients directly give me probabilities associated with values of k. So I can think of this as pk, yeah. So I hope you remember, understand the reason behind calling it pgf and not just any gf. So let us work this out for a few simple distribution. Actually, not these are some nice properties of the PGF. Remember, PGF has that expression. So I just want to see what happens if I set z to 1 in that formula. So gx of 1 will be, I just set z to 1 in all cases, and I just add all the probabilities. What should I get? 1.
1.
Yeah. So I learned a rule that I don't even know, even if I don't know anything about this x, one thing is for sure that remember, I cannot say any generating function, because this is only the PGF that has this property. Yeah. Why? Because if I replace this fxk with, let's say, any, if I replace this with the sequence ak, yeah, in the above example, what will I get here? This will be ak. Can I guarantee that any sequence will sum up to 1? Yes or no? I don't know anything about AK, so it can be anything. It can even be a divergent series. But I know these are probabilities, and I know that probabilities must add up to 1. So this 1 is because of probabilities. It's not because of generating function. Okay? So PGF evaluated at z equals 1 will always give me 1. This is a rule which you have remembered. If you want to apply PGF to. Now let us differentiate this now. At PGF with respect to z. Yeah? So I have PGF is sigma f. I will not write this subscript because you know what I'm doing. Fk z to kth, and I sum over k, and I differentiate this with respect to z. Differentiation is a linear operator, so it can go inside this summation. So it will be sum over the same k. F of k will appear as a constant because it doesn't depend on z. And what is the derivative of z to kth? K z to k minus 1. Why do I have to change the limits to start from 1 and not start from 0? Can anybody tell that? Because in the original it starts from 0. Why does it need to start from 1 now? The first one will be 0, yeah? So 0. So you are just wasting your time if you are including that. Yeah? And then you have problems with this. उसके बाद आप negative करना शुरू कर देंगे, so उसको आप पहले से निकाल दें. Okay, let's differentiate this once more. Now I differentiate this. So what will happen? That k was already there, and now you will have to bring that k minus 1 as well. And this will be z to k minus 2. And now this has to start from 2 because now k is equal to 1 also gives me 0. Now I'll stick to these two. Of course, if you want, you can move on with it as well. But do you see something here? You see this k times k minus 1. I have been telling you that this is very interesting. This k times k minus 1 will appear many times. So now substitute z equal to 1 in both these equations. What happens there if I set z to 1? So the first derivative at 1 will be, what do I get? Can anybody tell me? Sigma k fx of k. Yeah, because z is equal to 1 is 1. What is this? Quick.
PGF ये 1
ये तो PGF नहीं है ना, z तो निकल गया ना, तो PGF तो नहीं रहा ये. हाँ? क्या है ये? एक्सपेक्टेशन है x की, खत्म. ex, expected value of x. What is this? Let me set z to 1 here. What do I get? So gx double prime of at 1 what is this? This is also an expectation, but of what? Anyone? ये किसकी एक्सपेक्टेशन है?
x minus 1
x times x minus 1. जो ये फंक्शन है इधर भी आप वही लगाएंगे ना. ये तो नहीं है कि यहाँ पे x minus 1 और यहाँ पे आप k times k माने k कहाँ से आएगा? If I told you if this is g of x, this has to be g of k, yeah. So ये और इसमें कोई फर्क नहीं होना चाहिए फॉर्मूले में, ठीक है? This should also remind you why, and when we were discussing variance, I told you that this is easy to work with, yeah? Compared to ex squared and variance of x. Variance में क्या होगा ये? इसकी जगह variance में क्या होता? x minus mu squared, yeah? So compared to both of those, x minus 1 is much easier to deal with. And here is another reason, because this is, one reason was that telescoping method what I showed you in a video, and it has a connection with PGF as well. So double derivative of PGF evaluated at z is equal to 1 gives me the expectation of this quantity, yeah, x times x minus 1. And single derivative evaluated at 1 gives me expectation. So I have basically discovered these two nice formulas. Yeah, the expectation is just the first derivative at z is equal to 1. And if you are comfortable with your signals and systems, what is this there? Or you haven't started this yet, yeah? Or you must have started this in CVT, yeah? Z plane. So Z plane में Z is equal to 1 का क्या मतलब होता है? Don't tell me that this is unit circle, because Z is equal to 1 will be this point, yeah? Unit circle में क्या होगा? ये होगा ना? So this is different from that. Okay. What if I need variance? मुझे पता है वेरिएंस का ये फार्मूला लास्ट टाइम हमने डिराइव किया था, yeah, because I know x times x minus 1 उसका expectation and mu times mu minus 1. I plug this, basically those two, and I get a nice formula for variance as well. So once I know PGF, I can know variance and I can know expectation. So now I want to tell you why convolution is important in probability. Okay? So let me start with any two independent random variables. Remember, two and independent. Independent is a must here. And I don't care anything else. X1 and X2 can be any random variables. They can be binomial, they can be Bernoulli, they can be geometric. I don't care. Continuous, discrete. No, for here I have to stick to discrete, yeah? Because I want to basically, it's not that you cannot imagine sum of two independent random variables that are not discrete but continuous, but then the PGF will not be useful. I want to make the connection to PGF, so that's why I have to stick to discrete random variables. That is one requirement. The other requirement is that the values must be these values. Yeah. For some, of course, the probabilities will be 0. I want to ask a question here. What if I have a discrete random variable which has values different from integers, from these positive integers? Let's say I have these values, for example, 2.5 or minus 2.5, 4.5. How can I make my PGF useful for that case? Can anyone give an idea? How can I bring it to nice values? What do I need? I can always do something to bring a given probability distribution to a distribution with different values.
Transformation.
Transformation. I can always go for transformation. I told you. So you bring it to the right, analyze it, and when you're done with the results, you can always go back. It's like Laplace transformation. Yeah? So do not think that this PGF method is actually limited in its scope. It's up to you. You have to actually make sure that you bring a problem. ये जिस तरह अक्सर लोग कहते हैं ना कि आप ये जो डिस्कशन में अक्सर कुछ लोग होते हैं वो हर टॉपिक को अपनी तरफ खींच लेते हैं फिर आपको बीट करते हैं. So you bring every problem to PGF. It's up to you. So now let's say that I have two random variables x1 and x2, and I know their distributions. I know x1 is distributed according to some probability distribution. x2 is some. I don't have to know it, but I assume that I will know it. Okay. So now, which means that I will know the PDF and I will know the CDF and so on. And it also means that I will know the PGF. Yeah, because knowing the PDF means that I also know the PGF. GX1, I know GX1 and I also know GX2. GX1 is the PGF of X1 and it's the PGF of X2. And I must assume that they have a common support. How can I make sure that they have a common support? Even if it is not, that is what you do in convolution. Let me just give you an example. How you make sure that you have a common support. Let's say x1 is non-zero for 0, 1, and 2. Yeah? And let's say x2 is non-zero for 1, 2, and 3. So how to actually construct a common support? What will you do?
Transform and shift them.
ट्रांसफॉर्मेशन यहाँ पे नहीं करनी ना, ये ऑलरेडी इंटीजर्स हैं. पॉजिटिव। हमें पता है कि पीजीएफ में हम 0 प्रोबेबिलिटी अलाउ करते हैं ना। तो अब यहाँ पे देखो ना, इसकी कुछ प्रोबेबिलिटी होगी, इसकी कुछ होगी और इसकी कुछ होगी। सिमिलरली इसकी कुछ प्रोबेबिलिटी होगी। हम क्या करेंगे, हम इसको 0 प्रोबेबिलिटी असाइन करते हैं और यहाँ पे इसको, नाउ दे हैव अ कॉमन। मतलब सपोर्ट की मीनिंग वो नहीं है, ऑफ कोर्स आई शुड नॉट यूज द वर्ड सपोर्ट, बट आई जस्ट I just call it the countable set here. I just call it, give it a new name. क्योंकि PGF के लिए मुझे 0 से स्टार्ट करना है हर दफा, and I have to end up. तो ये फार्मूला जरा ज्यादा आसान हो जाएगा. Now let's say that the sum of these two, I give it the name X. तो मुझे इसका PDF चाहिए. क्या चाहिए इसका? Discrete PDF चाहिए. Discrete PDF में क्या क्वेश्चन होता है मेरे पास? X equals some value which I specify. So I start with this question, and this I don't change K because I have specified this. I replace X with sum of these two. Now, do you agree with me that this sum K can be achieved in many ways? X1 can take any value. It has to be, of course, non-negative integers. X2 can take any non-negative integers, but I require that whatever values they take, those values must add up to K. And because there are many ways of doing that,
That
I
is
will
supposed
take...
to be different, right?
क्या? Sorry?
X1 और X2 different होंगे ना?
नहीं, X1, X2 different random variables है. ट्रायल जरूरी नहीं कि वो किसी ट्रायल के साथ हो. ये डिफरेंट ट्रायल से भी हो सकते हैं. एक ट्रायल पे भी आप 2 रैंडम वेरिएबल एसोसिएट कर सकते हैं ना. रिमेंबर, इंडिपेंडेंट होना जरूरी है. अब इंडिपेंडेंस एक ट्रायल में भी आप कर सकते हैं और डिफरेंट ट्रायल में भी कर सकते हैं. इट डिपेंड्स ऑन हाउ यू. इंडिपेंडेंस के लिए क्या, ये वैसे आपने अच्छा क्वेश्चन किया है. नॉर्मली वी एसोसिएट इंडिपेंडेंस with different trials. ये common assumption होती है कि जब तक trials different नहीं है. So remember, independent trials and independent events are two different things. अब अगर trials different है फिर तो random variables definitely, let's say x1 is defined on the first trial and x2 is defined on the second trial, then they are definitely independent. But I can have both of them defined on the same trial. I can still make them independent. और उसके लिए क्या condition है? Let me remind you. What is the condition for two events to be independent? Let's say event A है. Let's go back to probability here. And event B है. What must the probability of their intersection be? P of A.
Disjoint जो था.
Disjoint नहीं है ना. It's independent.
वो P of A and P of A multiply by P of B.
Yeah. Don't you think this is possible in the same trial? It depends on how you A और B को आप, ये आपकी मर्जी, आप A और B ऐसे चूज करें जिसमें ये आपको मिल जाए. No problem. It is possible. You just check it. I can also and what was the random variable version of this? Random variable में ज़ाहिर बात है events तो नहीं होंगे ना आपके पास. Random variables होंगे. So remember, what is the most general probability for a random variable? The CDF, yeah? So, and this will be the CDF of Y. Let's say I have 2 random variables. In this case, let me just write x2 so that you connect it here. So I write x2. Let's say you evaluate this at x1 and you evaluate this at x2. This must equal the joint distribution. I told you about this in one of the lectures. Joint distribution must equal this product. And when you have that, you have independent random variables. They may or may not correspond to independent trials. Of course, you have to be you have to be inventive to come up with those, but it is possible. Okay. So, do you agree with me now that I need to take this union, and this union will only include sets that satisfy these two values. Yeah, you can choose any I and j as long as they add up to k. This union will give you that event. Is this clear? For example, I can just give two possibilities and you imagine the rest, yeah? So one possibility is that x1 takes 0 and x2 takes, tell me, what must be the value of x2? For this to be the case. Anyone? क्या लिखूं मैं यहाँ पे? K. दूसरा एग्जांपल, x1 equals 3. What must be x2? तो यहाँ पे क्या लगाना पड़ेगा मुझे? क्योंकि ये भी हो सकता है और ये भी हो सकता है. यहाँ पे क्या लिखूं?
k-3.
k-3. Yes. Because otherwise they will not add up to 3 to k. So this union means that you have to take the union of all such events. Yeah. Do you agree with me that it's the same as this? Basically यही concept मैंने use किया ना, कि if x1 is I, x2 must be k minus I, and you can only go from 0 to k. यहाँ पे कुछ भी हो सकता था, यहाँ पे k से आगे आप क्यों नहीं जा सकते? Anyone? For that you just imagine a value larger than k and you will see the problem. Yeah. So let me imagine a value of I which is larger than k. What should I write if I should be larger than k? x1 is equal to, let's say, k plus 1. In this case, I will be larger than k. Agreed? So what must be k2? Tell me.
So x2.
x2, yeah. Sorry, what must be x2? यहाँ पे मैंने पहले ये समझे ना कि यहाँ पे मैं ये बता रहा हूँ कि यूनियन 0 to k तक ही होगा, और यहाँ पे मैं कह रहा हूँ कि नहीं यार, ये मैं चेक भी करूँ क्यों. So let's choose a value larger than k. This is larger than k. यहाँ पे क्या होगा? k minus what?
k minus k plus 1.
K minus k plus 1, which means that this must be equal to
Plus 1.
minus 1.
Minus 1. Yes.
Yeah. तब अब आप चेक भी कर सकते हैं ना, इन दोनों को ऐड करें, आपको क्या मिलेगा? k मिल जाएगा ना. अब इसमें क्या प्रॉब्लम है? हमारे पीजीएफ में assumption होती है कि आप 0 से स्टार्ट करेंगे. तो ऐसा नहीं है कि आप कर नहीं सकते, ये आप कर सकते हैं, लेकिन वो सारे क्या होंगे? वो सेट्स क्या होंगे? सारे एम्प्टी होंगे. तो आप एम्प्टी का यूनियन लेते हुए अपना टाइम ज़ाया करेंगे ना. यूनियन एम्प्टी आप करते जाएं, तो जिंदगी आसान करो, आप सिर्फ k तक करो. ठीक है? You do the same in convolution. Convolution में when you're dealing with causal signals, you have lots and lots of zeros in which and you can eliminate that. Yeah? अब इसके बारे में कोई बता सकता है कि ये जो इवेंट्स मैंने लिखे हैं जिनका मैंने यूनियन लिया है ये क्या है आपस में? दे आर x1 x2 तो इंडिपेंडेंट थे ना, या वो इंडिपेंडेंट? ये क्या है? ये जो इवेंट्स है, फॉर एग्जांपल I is equal to 0 के लिए, let me give it a name. Yeah, let me call this A0. तो I is equal to 0 के लिए A0 हो गया. अगला क्या है? A1. अगला क्या है? AK. ये सारे इवेंट्स सबका मैं क्या ले रहा हूं? यूनियन. या तो ये आपस में क्या है ये इवेंट्स? कैन यू टेल मी? there is a name which you should remember. They are disjoint. डिसजॉइंट है ना, क्योंकि x1 दो वैल्यूज तो नहीं देगा ना किसी को. x1 ने एक वैल्यू दे दी, फॉर एग्जांपल 0, तो वो 0 किसी और मतलब वो उस सेट को 0 के अलावा 1 नहीं देगा. 1 जब देगा वो दूसरा इवेंट बन जाएगा. फंक्शन ठीक है ना, वो एक यूनिक वैल्यू देता है. एक सेट को वो दो वैल्यू नहीं देगा. ये बात समझ आ रही है? अब इसका क्या फायदा है? To know that they are disjoint, इसका फायदा हमें तब लगेगा जब हम probability लेंगे इनका. I will take the probability of this union, and that will give me the sum of these probabilities. You get it? That's the advantage of having a disjoint union. The law of total probability can be applied because they are disjoint. And the probability of this event is exactly the PDF of that sum. Remember, x was sum of these random variables. अच्छा, अब यहां पे आपको एक और चीज इंटरेस्टिंग नजर आ जाएगी. ये जो probability है, let me just write this down. ये क्या है जिनको मैं ऐड कर रहा हूं? फॉर एग्जांपल ये तो मैंने बाद में लिखा है ना. ये ओरिजिनली क्या था? P of x1 equals I comma x2 equals क्या माइनस I. और कॉमा से हमारा मतलब क्या होता है?
मैंने नहीं खाना. प्लीज मामा ये ले जाए.
कॉमा से हमारा क्या मतलब होता है?
अलिशा आपका माइक.
Intersection, yeah. So intersection of two events. When can I write this as a product of these two probabilities? Product of x1 equals I and x2 equals. When can I do that? When x1 and x2 are. अब आपको समझ आइए इंडिपेंडेंट assumption हमने क्यों लगाई थी? अगर ये दोनों इंडिपेंडेंट ना होते तो हम इस स्टेप से आगे नहीं जा सकते थे. We have to stop there. But because we assumed them to be independent, I can break this down into a product of two probabilities. And each one of them is a PDF. This is the PDF of x1 at I, and this is the PDF of x2 at k minus I. And what have I achieved at the end. ये sum क्या है? This sum is the convolution of the two PDFs. समझ आ गई आपको ये बात? It is the convolution of two PDFs. अगर ये समझ नहीं आई तो पूछ लें before I move on, because this is very important. We have arrived at a very important result of probability. Let me just write this down, what we achieved. What we achieved is that the PDF of a sum of two random variables, PDF of a sum of two random variables will always be equal to the convolution of the individual PDFs, provided x1 and x2 are independent. ये independent आप याद नहीं रखेंगे तो गड़बड़ हो जाएगी. You will try to apply it to, जिस तरह सिग्नल सिस्टम में कन्वोल्यूशन के लिए क्या रिक्वायरमेंट है, कोई बता सकता है? वहां पे भी आप कन्वोल्यूशन लगाते हैं ना, वहां पे assumption क्या होती है? You have a system and let's say impulse response उसका h है, and you apply a signal x, so you say that the output will be h convolved with x. याद आ रहा है आपको? इसके लिए क्या assumption है? जिस तरह यहाँ पे assumption क्या है कि x1 and x2 must be independent, यहाँ पे assumption क्या है? अगर आपको assumption नहीं पता तो आपको सिग्नल सिस्टम की हवा नहीं लगी, आप वैसे ही पढ़ रहे हैं, फिर टाइम ज़ाया कर रहे हैं. You must know the assumption. Anyone? Hint में देता हूं, वो assumption सिग्नल के बारे में नहीं है. सिग्नल जो मर्जी है दे दे, वो assumption किसके बारे में है? सिस्टम के बारे में है. सिस्टम को क्या होना चाहिए? क्या? बता दें, क्विकली बता दें, क्योंकि ये मैं कोई क्वांटम मैकेनिक्स का क्वेश्चन नहीं पूछ रहा है, बहुत आसान है. So unfortunate. या बताना नहीं चाहते या याद नहीं आ रहा आपको?
स्टेबल सिस्टम.
स्टेबल बहुत आप आगे चले गए ना, थोड़ा सा बेसिक आ जाए ना. कन्वोल्यूशन आपने कब पढ़ा है? उस टाइम स्टेबिलिटी की बात नहीं होती थी. इसका पता है क्या मतलब है? अगर आपको ये याद नहीं आ रहा कि देखो ना, ये याद रखना कि x1 और x2 इंडिपेंडेंट है, इसके लिए इस प्रूफ को समझना जरूरी है या नहीं है? क्योंकि देखो ना, हमें किस स्टेज पे पता चल रहा. अब आपको समझ आइए कि प्रूफ क्यों इंपॉर्टेंट होता है. हम कहते हैं ना प्रूव इट. प्रूफ का मतलब सिर्फ मैथमेटिकल नहीं होता. द प्रूफ टेल्स यू व्हाट assumptions वर इन्वॉल्व्ड इन अ रिजल्ट. ये डेरिवेशन आप नहीं करेंगे तो आपको ये इंडिपेंडेंस वाली बात समझ भी नहीं आएगी कि इंडिपेंडेंट, व्हाई डू आई नीड x1 and x2 टू बी इंडिपेंडेंट, क्योंकि इस स्टेज पे आप फंस गए ना. इसी तरह अगर आपको कन्वोल्यूशन वाला ये प्रूफ आपने समझा होता तो आपको याद होता कि at which stage you needed certain assumption, and those assumptions are two. You need linear system as well as
टाइम एंड वेट.
जब तक ये दोनों नहीं होंगे तो ये नहीं होगा. लीनियर है, टाइम इनवेरिएंट नहीं है, फिर भी ये नहीं हो सकता. टाइम इनवेरिएंट है, you need both. अब आप जाके, आई एम नॉट योर सिग्नल एंड सिस्टम्स टीचर, लेकिन मुझे आप लोगों ने कंसर्न जरूर किया है, ठीक है? सो
प्रूफ में जो आपने इंडिपेंडेंट वाली बात बताई, रिपीट कर दें.
अच्छा ठीक है, जब आपको इंपॉर्टेंस समझ आ गई है तो आप दोबारा पूछ रहे हैं ना. हम यहां तक आ गए थे ना. We started with that sum because Why do we need this sum? Because we need the PDF of the sum. Then we broke it down to a disjoint union. We applied the law of total probability, and it turned out that we have to take the probability, the sum of these probabilities. Which probabilities? The probability that x1 takes any value I, and x2 must take k minus I, and n between them was a, because comma or intersection का एक ही मतलब होता है. अब you are taking the intersection of two events and you are writing this as the product of two probabilities. ये आपने तभी लिखा है ना ये वाला. And this product, the PDF of x1 at I multiplied by the PDF of x2 at k minus y, ये multiplication कहाँ से आई है? ये यहाँ से आई है कि आपने इंटरसेक्शन की प्रोबेबिलिटी को मल्टीप्लिकेशन ऑफ प्रोबेबिलिटी. इसके लिए आपको क्या चाहिए? क्योंकि ये इवेंट्स x1 और x2 के बारे में है ना. बेसिकली इवेंट्स इंडिपेंडेंट है. क्यों इंडिपेंडेंट है? क्योंकि रैंडम वेरिएबल्स इंडिपेंडेंट है. I would encourage you to go back to signal system, understand that proof, and tell me. You can actually write me or attempt. Tell me, आप इसको proof करके एक यहाँ पे error लगाएं कि this is the point where I need linearity and this is the point where I need. ये आप करेंगे तो फिर आपको समझ आ जाएगी, वरना you just have to memorize that. Okay. ये है कि हमने एस्टेब्लिश किया कि सम ऑफ रैंडम के केस में मुझे इन्वॉल्व करना पड़ रहा है, बट कन्वोल्यूशन इज नॉट अ वेरी इजी थिंग टू डू. सो नाउ वी नीड टू, बट वी हैव प्रूव्ड समथिंग ऑलरेडी अबाउट पीजीएफ. पीजीएफ के बारे में मैंने क्या प्रूव किया था थोड़ी देर पहले? लेट मी गो बैक. वी प्रूव्ड समथिंग which we will now put to use. And that was this thing. वो जो दो sequences के लिए हमने prove किया था कि whenever you have two sequences, the convolution of those sequences in this language will simply be a product of their PGFs. तो वहां पे भी यही होगा कि चलो PDF के साथ जब आप डील करेंगे तो you will have to deal with convolution. लेकिन अगर इसी पीडीएफ का मैं पीजीएफ ले लूं और उन दो का भी मुझे पीजीएफ पता हो, सो आई सिंपली नीड टू मल्टीप्लाई. सो दैट कन्वोल्यूशन बिटवीन, लेट मी जस्ट राइट दिस डाउन हियर, दैट कन्वोल्यूशन बिटवीन द टू डेंसिटीज, द टू पीडीएफ्स, corresponds to the algebraic multiplication of their respective what? What am I multiplying here? The two?
PGF?
PGF, exactly. अब आप मुझे बताओ ये आसान है या ये आसान है?
मल्टीप्लिकेशन आसान है.
अब मुझे बताओ वहां पे आप क्या करते थे? क्या आप मल्टीप्लाई करते थे जिंदगी आसान बनाने के लिए? सिग्नल को आप किससे रिप्लेस करते थे?
लेप्लास.
ट्रांसफॉर्म जो भी है, लेप्लास हो, फोरियर हो, जितने भी है, सब में इक्वालिटी है. सो बेसिकली ये जो पीजीएफ है ये आपका वो ट्रांसफॉर्म है. वहां पे आप सिग्नल का ट्रांसफॉर्म लेते हैं, यहाँ पे आप पीडीएफ का ट्रांसफॉर्म लेते हैं. समझ आया मुझे बात? ओके, सो लेट्स नाउ, बिकॉज नाउ वी आर रेडी टू अटैक दैट प्रॉब्लम ऑफ टू डाइस. टू डाइस में हमारे पास यही प्रॉब्लम था ना कि वी हैड टू डाइस. लेट्स से इसका अपना सैंपल स्पेस है, इसका अपना है. सो एंड वी आर इंटरेस्टेड इन द टोटल नंबर ऑफ डॉट्स. So if x1 is a random variable which represents the number of dots, yeah, ऑन द फर्स्ट डाई कि कितने डॉट्स ऊपर आ गए, और x2 कितना है दूसरे का है, सेकंड का है. Because the die was fair, so both of these random variables are uniformly distributed, discrete uniform, and they are both distributed, yeah, uniformly. और 6 का मतलब ये है कि 1 up to 6 वैल्यूज हैं इसकी, ये 1 up to 6. मुझे x1 का भी पता है, x2 का भी पता है. अब pgf क्या होगा इसका, थोड़ी देर पहले हमने किया हुआ था. I know the pgf of x1 and I know the pgf of x2. Basically they are the same क्योंकि they are both following the same distribution. किसको याद है, थोड़ी देर पहले हमने किया था ये. वैसे एक्सप्रेशन तो मुझे भी याद नहीं है. Let's go back quickly.
1/6 summation of
Summation 1 to 6.
Okay, so इसका मतलब कि आप लोगों की मेमोरी ठीक है, मेरी खराब है. It was sum of 1 over इन बार लगा दिया था हमने, ठीक है. 1/6 हो जाएगा ये, and this will be z up to k, and k goes from 1 to 6, ठीक है. और यहाँ पे क्या है, they will all multiply by 1/6. So हाँ, ये मैंने यहाँ लिख दिया, ठीक है. For both the PGF will be of this form. So now I want to know, because असल में तो मैं interested हूँ PDF of x1 plus x2. मुझे असल में ये चाहिए, लेकिन मुझे पता है कि PDF से पहले अगर मैं PGF निकाल लूँ तो ज्यादा आसान है. तो PGF में दोनों को मुझे क्या करना पड़ेगा, मल्टीप्लाई करना पड़ेगा, ठीक है. I just multiply these two, और आपको पता है कि this will be, remember it starts from 1, okay, not from 0. Although you have to start from 0, लेकिन वहां पे 0 पे उसकी probability क्या है, 0 पे क्या है probability,
0.
k is equal to 0 पे 0 है ना, और 6 के बाद भी 0 है. तो इसलिए मैं बताया था कि PGF का जो फार्मूला है, बेशक वो 0 to infinity हो, आपको मसला नहीं करेगा क्योंकि आप एक्चुअल फार्मूला सिंपल ही होगा. नाउ इट्स एक्चुअली स्टार्ट, remember a common mistake is to start from 1. It is not starting from 1, it is not 1 plus z, it starts from z. So this one is basically z plus z squared up to z, the sixth power, and each multiplied by 1/6. And same goes with this one. अच्छा. So आप मल्टीप्लाई करेंगे और ये 36 बाहर आ जाएगा, और चूंकि इसमें भी z है और उसमें भी z है, वो z स्क्वायर बाहर आ जाएगा. And then I can group them up if you are careful. 1 और z to 10th का एक ही मामला है. Basically 10th 12th है और is 1 z squared है, तो इन दो के साथ 1 आ जाएगा क्योंकि एंड पे है. Yeah? ये 2 दफा आएंगे तो 2 है. You can verify this, yeah? And some, और ये दोबारा मल्टीप्लाई करें क्योंकि ये हमने सिर्फ आसान बनाने के लिए किया था. And you can now look at this. You can see a pattern. ये तो आप खुद कर लेंगे, ये सिर्फ अलजबरा है. I just want to explain how did I write this one, yeah? So पहले इस पे फोकस करें. For k from 2 to 7, 2 to 7 मतलब है कि हम focusing only on this part, ठीक है. मैं इस पे फोकस फिलहाल नहीं कर रहा क्योंकि 7 से ज्यादा है. इस समेशन में किस पे फोकस करूंगा, इस पे, और way back to this one and the last one. यहां पे हम ऐड कर रहे हैं, यहां पे इसलिए ऐड नहीं करना पड़ रहा कि आगे नहीं है ना, वो z7 एक ही दफा आएगा, 2 दफा थोड़ी आएगा. ये तो चूंकि डिफरेंट है तो इसलिए ऐड हो रहा है. z to 7 plus z to 7 आप करके गलत करेंगे फिर. So do you agree with this formula that if x of k is basically k minus 1 divided by 36, 36 डिनोमिनेटर में है और ये k minus 1 क्यों है, क्योंकि ये इसके साथ 1 है, इस z² के साथ क्या है 1 है, और z³ के साथ क्या है, तो हर दफा ये कोएफिशिएंट उस एक्सपोनेंट से 1 लेस है। देखो ना, ये 5 is 1 less than 6, this 6 is 1 less than 7, so each coefficient is 1 less than the corresponding exponent. This is basically the exponent and this is the difference. अच्छा, कोई मुझे बता सकता है कि पावर और एक्सपोनेंट में क्या फर्क है? हम ये दो नाम यूज करते हैं ना। सो इफ आई राइट x क्यूब, इसमें पावर क्या है और एक्सपोनेंट क्या है? एनीवन? 3 क्या है? व्हाट इज 3?
एक्सपोनेंट।
हाँ, तो पावर क्या होगा फिर?
1।
नहीं। एनीवन? कुछ लोग इसको भी पावर कहते हैं ना, लेकिन पावर नहीं है। अगर ये पावर होता तो किसको इतना फारिग नहीं था कि दो दो नाम रखता ना। देयर मस्ट बी रीजन।
Power is an operation. It's not a
This result is power. This is called the third power. So 9 is the second power of 9. 9 is the second power of 3. Yeah, and 27 is the third power of 3. अच्छा, अब आप उस पे आ जाएं। ये जो सेकंड पार्ट ऑफ ईच सम है ना, इसमें आप क्या पैटर्न नोट कर रहे हैं? यू नो दैट z² और z12, सो 2 पे जो PDF है और 12 पे है, वो दोनों सेम है। दोनों के दरमियान क्या डिफरेंस है? बल्कि डिफरेंस को छोड़ दें। Tell me something which is common as you go from this term to that term, and from this term to each time there is one thing that is common. Add the two. What is 2 plus 12? 14. What is 3 plus 7? And what is 6 plus 8? They all add up to the same number, and that is, और ये तो निकल गया ना, क्योंकि ये तो 7 के साथ आ गया। So which means that the PDF at k is the same as the PDF at 14 minus k. इसको आप वेरीफाई कर सकते हैं। k जब 2 होगा तो f of 2 will be the same as f of 12. When this is 3, when k is 3, this will be 14 minus 3, which is 11 and so on. समझ आ गई बात? And now I can write. अच्छा, यहां पे आपको समझ आ जानी चाहिए कि मैं ये बार बार ये हैश क्यों यूज कर रहा हूं। यहां पे अगर मैं हैश यूज ना करूं तो क्या मसला हो जाएगा? लेट मी जस्ट आस्क यू। लेट्स से मैं सिर्फ यहां पे f लिख देता हूं। What will be the problem here? Tell me.
K will take all values from the real time.
क्योंकि जो इसके अलावा वैल्यू है उस पे 0 है, ये इस इक्वेशन में नहीं पता चल रहा मुझे। फॉर k आउटसाइड दिस इंटरवल, और इसमें ऑटोमेटिकली वो भी आ गए ना, वो बेसिकली ये सिर्फ 2 to 7 नहीं है, वो अप टू जो है ना 14 मुझे वैल्यूज मिल रही है। ठीक है, तो बाकियों पे 0 है, ये कहां लिखा है? समझ आ गई? तो इसलिए जो मैं फार्मूला लिखूंगा वो फार्मूला मुझे पता है कि एक और फंक्शन है ये। सो अगर मुझे PDF लिखना है, फार्मूला बेशक मैं वही यूज करूं। सो आई नो दिस फार्मूला इज वैलिड फॉर 2 to k। तो यहां पे मैं डिराक डिस्ट्रीब्यूशन मुझे हेल्प कर रहा है इसको फिल्टर करने के लिए। दिस विल अप्लाई अ फिल्टर बेसिकली। ठीक है ना? So k belongs to 2, 7, only then this term will be applicable. Outside this interval, even though if you write this thing, it will multiply 0 when k is outside 2 to 7. Similarly, 8 to 12 के लिए मुझे ये क्यों चेंज करना पड़ा ये? Can anyone tell me? 8 to 12 के लिए यहाँ तो वो सेम है ना?
14 minus k minus 1.
Basically, I have to. इसका मतलब ये है कि k has to be replaced. If you want to use the same expression, you have to replace k with 14 minus k. So k को मैं 14 minus k से replace करूँगा. K will be replaced with 14 minus k. So fx basically डिनोमिनेटर में फिर भी 36 आएगा, -1 अपनी जगह, and k has to be replaced with 14 minus k, and that's why I get 13 minus k. Now this is a PDF क्योंकि these deltas will ensure that I get a 0. जब तक मैं 0 को इंक्लूड ना करूं, मैं इसको PDF नहीं कह सकता, मुझे वो हैश लगाना पड़ेगा, वो हैश. That hash is important. Sorry. Okay, let's so far we have established the sum of two independent RVs, random variables, and I know that the PDF of their sum is the convolution of their individual PDFs. Yeah. Achha, can anyone tell me that when I am writing this expression, I am not writing this argument? मैं ये x यहाँ पे क्यों नहीं लिख रहा? यहाँ पे मैं इसके बगैर क्यों कर रहा हूँ ये? Why am I writing this only for the functions and not for? Why do I not include the values? कि convolution किन दो चीजों के दरमियान होता है? These two objects must be, there must be sequences, and when you plug a value, you are taking just a value of that sequence. ये बात समझ आ रही है? So convolution, अगर मैं यहाँ पे x लिख दूंगा, so it will become convolution between those two values, and it's wrong. इसका मतलब ये भी है कि जब आप ये लिखते हैं ना उधर, when you write this thing, there is a serious problem here, because you are trying to convolve two values. X of k is a value. So although the authors don't care about this, but the correct notation is this. Okay, this is the only correct notation. k आप उसके बाद लगाएंगे तो आपको values मिल जाएगी उसकी. So let's get to this. So what if I have a sum of several random variables? Because we will need that. Let's say I have a sum of n random variables, and they are all independent. They are all independent. चेक करूं कि कोई माउस तो नहीं हुआ ना? आ रही है आप लोगों को आवाज ना?
Yes, sir.
ठीक सही. अच्छा, so now I want to establish the rule for n independent variables. So it's a sum of n random variables. अच्छा, इसको जरा आसान बनाने के लिए I am using the symbol s with the subscript n. n यहाँ लिखने का मतलब ये है कि I am talking about n random variables. ठीक है? तब यहाँ पे n-1 होते हैं, n-1 हो जाएगा. अच्छा, for reason you will see later, let me define this s for 0 as well. 0 का क्या मतलब है कि I have nothing to start with. I have no random variable. So s0 will be 0 because I am not adding anything. Okay. Now, do you agree with me that for k, for each value of k from 1 to n, this is true? Can you justify this? I can justify it like that. I can show it for n basically. So let me write this. Let me write xn outside as a separate term. So what will be the remaining term? It will be from I from 1 to क्या होगा इधर? n minus 1. What is that? It is s n minus 1 plus xn. अब आप n की जगह k लिख दे तो ये आ जाएगा. So it's okay. Which means that I can apply this rule. और 2 का मुझे पता है कि जब 2 को मैं ऐड करूंगा और इंडिपेंडेंट ही, जब सारे इंडिपेंडेंट है तो ये दोनों भी आपस में इंडिपेंडेंट है. So when I multiply these two, actually I can start from the original Sn जो given है, जो मैंने जिस तरह मैंने एक्सप्लेन किया है. तो xn और Sn minus 1 इन दो का आ जाएगा. बेसिकली ये इसने यही किया है ना. ये पहले इस पे अप्लाई करो आप, ठीक है. तो s का pgf और x का pgf, फिर आप इस तरह छोड़ो कि इसको, ये तो एंड पे आ गया. अब s को आप ब्रेक करो दो में, Sn-1 को ब्रेक करो तो फिर इन दो का प्रोडक्ट, एंड यू कैन move on. At the end you will have the product of all PGFs basically. So basically the rule of this convolution that you can have any number, any finite number of random variables, and if they are independent, the PGF, sorry, मैं PGF पे लिख दूं, the PGF of that sum will simply be the product of the individual PGFs. And that also means that convolution का भी वही है कि उनका जो PDF होगा, उन सब का जो PDF होगा, that will be the convolution between the individual PDFs. So यहाँ convolution, यहाँ पे multiplication, और ये rule सिर्फ 2 के लिए नहीं है, multiple के लिए भी है. Now we are ready to actually, यहाँ पे कोई क्वेश्चन है तो आप पूछ लें क्योंकि टॉपिक चेंज हो गया ना. एनी क्वेश्चन? अच्छा, अगर क्वेश्चन नहीं, मतलब ये अभी आगे चीजें बेसिकली हमने जो पीजीएफ के लिए डिस्कवर किया है ना, यही अब बार बार यूज होगा. सो लेट्स से बर्नौली ट्रायल्स आपके पास हैं. यू हैव अ सीक्वेंस ऑफ बर्नौली ट्रायल्स. वहां से कौन कौन से डिस्ट्रीब्यूशंस आप इमेजिन कर सकते हैं. सो यू विल हैव अ सीक्वेंस ऑफ बर्नौली ट्रायल्स, ईदर अ फाइनाइट number of Bernoulli trials or infinite, whatever. Depending on the question you ask, many variables can actually emerge. So let's say we have a sequence of Bernoulli trials, 1 trial, 2 trials, and so on. And at each trial, you define a Bernoulli random variable. So x1, x2, and imagine that they all have the same probability P of success. Probability of success. And xi, x1, x2, they all are Bernoulli, which means that they will give me 1 when I get a success, and they will give me 0 when I get a failure. And this is something which you have seen over and over, so I don't need to explain it. Okay. So each of these xi's, yeah, x1, x2, and so on, because they all are Bernoulli and they all have the same probability P of success, they will have the same PGFs. So it's called Bernoulli PGF. It's just the same name. Instead of saying PGF of Bernoulli random variable, you can say Bernoulli PGF to simplify the language. So do you agree with me that the PGF of this Bernoulli will always be the same? Can you agree with me on this? Let's say you forgot the previous derivation. Why should this be the PGF of a Bernoulli random variable? Why? Can anyone explain that? Just look at the exponents of z, yeah? The exponent of z here is 1, yeah? 1 is a success. So you multiply it with the success probability. Here the exponent of z is 0. 0 is a failure, and here it's the failure probability. So the PGF is actually, it includes everything, yeah? It is a complete description of the distribution. Tells you everything. So we can now ask certain questions. Yeah? Let's say I am interested in one of these quantities. So I can be interested in the number of successes in n trials. But can you tell me how can I represent this? So अगर इसको मैं x कह दूं, so can you tell me how will it relate to those x1 and x2 and up to xn? क्या relationship है इसका? How will the number of successes as a random variable in n trials relate to those individual Bernoulli random variables? क्या होगा इनके दरमियान? बताएं? Each of them is 1 for a success, 0 for a failure. So you are adding how many ones? As many as there are successes. तो ये क्या होगा? x1, x2 up to xn के साथ क्या लगाना पड़ेगा मुझे? Addition. I just have to add them. अच्छा, ये मुझे बताएं. Let's say मैं दूसरा क्वेश्चन पूछ लेता हूँ. Number of trials until the first success. So let's call it k. Yeah? So k is the number of trials until the first success. How can I link this to my x1 and x up to xn? इसके लिए क्या relationship है? Anyone? अब मैं ये तो नहीं ले सकता ना कि k is equal to x1 plus x2 plus x3. It will be totally wrong. Like I can do something. And of course, I don't expect too much from you because you are new to this language. Let me write something. इसको मैं कैसे लिख सकता हूँ फॉर्मूले में? ये लिख सकता हूँ मैं? ये ठीक है? अब मैं यहाँ पे मैं आपको एक हिंट देना चाहता हूँ. यहाँ पे आप ये क्यों लिख रहे हैं? क्योंकि आपको पता है कितने ट्रायल्स है ना? आपको पता है कि अगर ये n ना पता होता तो आप ये लिख सकते थे. ये नहीं लिख सकते थे ना. सो अब यहां पे बेसिकली ये है कि आपको ये पता ही नहीं है कि कितने ट्रायल्स हैं. सो आई कैन स्टिल राइट दैट समेशन. It will still start from 1 and I will still write xi, but this number is not known. This is a random quantity. So if I call that k, I can write it there. Do you understand this sum? It is a sum of Bernoulli random variables, but I don't know how many. It is a random sum. The number of terms in this summation is random. ये बात समझ आ गई? अब जो मुश्किल बात है ये है कि इस फर्स्ट सक्सेस को मैं यहां पे कैसे रिप्रेजेंट करूं. तो दिस मस्ट इक्वल टू व्हाट? The sum must equal to what? 1. बेसिकली इसमें और इसमें ये फर्क है. वहां पे ये फिक्स था और जो एडिशन के बाद रिजल्ट आना था वो रैंडम था. ठीक है? एंड दैट वाज योर रैंडम. यहां पे आपने सम को फिक्स कर दिया and you don't know how many terms you need to add to get that one, क्योंकि ये कभी 0 होगा कभी 1 होगा, ये कब 1 हो जाएगा, क्योंकि जब तक आपको 1 नहीं मिलेगा ये 1 नहीं मिलेगा. So this is how you will tackle this problem. अच्छा, आगे जाएं. अभी मैं सॉल्व नहीं कर रहा, मैं आपको सिर्फ जरा दिमाग खोल रहा हूं कि कैसे ये चलेगा. ये नंबर ऑफ ट्रायल्स नीडेड अंटिल द rth सक्सेस. तो ये क्या होगा? सम I from 1
to R.
1 to
this will
R.
be still xi equals to r. So I am specifying the right. इस तरह linear algebra में आप सॉल्व करते हैं ना चीजों को. I'm specifying the right hand side and I'm asking how many terms do I need. ये जरा मुश्किल क्वेश्चन है. Number of successes in r trials. So it looks like that first question, yeah. वहां पे n है, यहाँ पे r है. And I want to put a condition required for n successes in a larger number of trials. मैं इसको जरा नंबर सिंप्लीफाई करता हूं कि आपको समझ आ जाए. लेट्स से मैं ये कह रहा हूं कि अगर मुझे 10 ट्रायल्स में फॉर एग्जांपल 6 सक्सेसेस चाहिए, कितना में? 10 में मुझे चाहिए, ये मुझे चाहिए, ये मेरा गोल है. तो मुझे ये बताएं कि जो पहले 5 हैं उनमें कितने सक्सेसेस होने चाहिए ताकि 10 में मुझे 6 मिल जाए. ये समझ आएगी ये बात? मतलब इसकी बात ये ऐसे ही है. आप अपने जीपीए को देखें, आप कितने सेमेस्टर होते हैं? 8 है ना. So let's say x1 is the score you get in first semester and x8 is the score you get in 8th semester. So this will be your total score. ठीक है. अब आप ये कह रहे हैं कि 4th semester तक मुझे कितना स्कोर चाहिए ताकि ओवरऑल मैं इतना अचीव करूं. ये कोई मुश्किल सवाल तो नहीं है ना पूछने में. इंग्लिश में आसान है लेकिन प्रोबेबिलिटी में बहुत टेढ़ा सवाल है. ठीक है, क्योंकि आप आगे का वो बता रहे हैं ना कि मुझे अगर पूरा एंड पे जो स्कोर चाहिए उससे पहले मुझे क्या चाहिए. सो दीज 4 सिनेरियोज विल गिव यू डिफरेंट डिस्ट्रीब्यूशंस. ठीक है. हमारे पास कितना टाइम है? खत्म हो गया टाइम?
जी सर, 1.5 आवर्स हो गया.
ठीक है, सही. हम कंक्लूड करते हैं कि इसके बाद मेरा भी अगला लेक्चर है. किसी के ज़हन में क्वेश्चन आ रहा है तो आप पूछ सकते हैं. ठीक है. बट दिस इज समथिंग यू लर्न बाय डिस्कशन. सो ठीक है, आपस में आप डिस्कस करेंगे और मोमल भी ये बीच में इंटरेक्टिव सेशन रखती है तो ये चीज़ें वो भी मतलब कवर कर सकती हैं. लेट मी स्टॉप द रिकॉर्डिंग. और कोई क्वेश्चन अगर है तो आप पूछ सकते हैं कि आई कैन फॉरगेट दिस.